Hello, in this video we will examine how students can use ClassWiz to support their understanding of trigonometric identities. Start by turning on ClassWiz and set it up, and we're going to use calculate mode in this video, so choose menu and number 1 for calculate. Make sure that the angles are measured in degrees as shown up here. To change the angle measurement, do shift and set up number 2 for the angle unit and choose number 1 for degrees, and the small d symbol up here tells us that it's degrees. For a statement to be an identity, it must be true for all values of the variables concerned. And let's look at a very important identity that students always study in trigonometry, the so-called Pythagorean identity between sine and cosine, as you can see written here. In words we say sine squared b add cosine squared b is equal to 1. The meaning of this identity is that we get the sine of an angle and square it, and get the cosine of the same angle and square it and add them up. On the ClassWiz, let's look at this on the ClassWiz. Sine of angle, we'll use angle b, alpha and b. Have to press alpha to get the variable. And squared, and cosine of angle B squared. Notice the idea is that we square the sine, not square the cosine, and the symbols here are a little bit different from down here. Students need to understand the difference. This is in fact a strange notation. So now to evaluate this expression of sine squared b add cosine squared b, the easiest way is to use the calc menu. So tap the calc command here, and we'll enter a suitable value for the variable b, for example 47 degrees, and tap equals. And ClassWiz has shown us that b is 47, and the value when we tap equals is 1. And we could choose a different value by tapping equals and put a different value in. Let's choose a large negative value, negative 234 for example, and the sine squared add the cosine squared is calculated by just tapping the equals key. That's also equal to 1. The result seems to be the same each time. If you change some different values, like let's try one more, 1.24, and the sine squared b add cosine squared b is 1. It seems that that's the case whatever values we choose for b. The concept of an identity is illustrated here. It's the same result all the time. Of course, students need to prove that an identity is always true, not just demonstrate it. All the ClassWiz is doing is demonstrating it, and they'll need to require some mathematical argument, not just evaluation. There's yet another way of using ClassWiz to think about this identity. We consider tables of two different expressions. So we'll go back here and we'll delete that expression and change it to sine of x squared. And the second expression we'll make 1 subtract the cosine of x squared. And we'll make a table for these two values for a range of values like negative 150 degrees up to 330 degrees in steps of 30 degrees. And when we look at the table of values, we see they're both the same. The sine of sine x squared and the 1 subtract the cosine of x squared is the same wherever we go. And if we change some values, change this value of 90, for example, to 84, then the two values are still the same. The values in each column continue to be the same regardless of the value. If we had a strange value like 45.123, whatever value you choose, the two values are the same. That is, it seems as if sine squared x is equal to 1 subtract cosine squared x is also an identity. In fact, it's merely a rearranged form of the same Pythagorean identity here, and we looked at these two functions. You can think of some well-known trigonometric relationships as identities too. For example, consider the relationship of tan x is equal to sine x over cos x. We can use a table to evaluate both of these functions. So let's, in the first place, put the tan of x, tangent function, and for the second case we'll put the ratio of the sine function to the cosine function. And so, sine x over cos x. Choose a suitable range of values. So let's choose the first two quadrants, 0 to 180 degrees in steps of 10. And when we create the table, it's clear that the two expressions have got the same value everywhere. You can see these two are always the same. Except, of course, when x is 90 degrees, we can't have the cosine of 90 degrees is 0, so we can't have the tangent and we can't divide by 0. But everywhere else it's the same. So if we choose other values of x by changing a value here, 256, we can see the same is true. So a table is a useful way to test whether a relationship seems to be an identity before attempting to prove it. A good example involves finding the sine of an angle that is twice as large as another angle. So a natural thing to think is, if we get the sine of an angle that's twice as large, is it 2 times the sine? And so we can explore that on the class whiz. The sine of 2 times x and twice the sine of x, 2 times the sine of x, and see whether these are the same. We'll start with some values. Let's start with some small values this time, say from 0 to 5 in steps of 1, and make the two tables. Here we go. And it looks like they're about the same. They're both 0, 0.348, 0. They're not quite the same. Not quite, but very close. So students might think, yes, it seems reasonable, but it's a good idea, of course, to check a wider range of values. So let's go back and check a bigger range of values, say 0 to 180 degrees in steps of 10, and see if they are in fact mostly the same. And you can see for small values, they're sort of the same, but as the value of x gets larger, the two values are clearly quite different. So the class whiz here helps us to see that while sine 2x is close to sine twice the sine of x when it's a small value, it's not in general the case that that is true. So the expression is clearly not an identity. In fact, the identity in this case related to the sine of twice an angle involves both the sine and the cosine functions. That the sine of 2x is actually equal to 2 times the sine of x times the cosine of x. And if we make that change, now when we draw the table, we can see that the two values are everywhere the same. And if we choose another angle to test it a little bit further, 57.4, then in fact they are still the same. So the expression is an identity. Some examples of where it doesn't hold are enough to show that something is not an identity. But we need to have a proof to show that something is an identity. This video has shown how to demonstrate and explore the idea of a trigonometric identity on ClassWhiz. Of course, algebraic identities can also be explored in exactly the same way. So let's look at this example. If we consider the function x times x add 1 and another function x squared add x, and look at these two functions on a range of values, say 0 to 25 in steps of 1, the two values are always the same. As you can see. And indeed, if we change the value of x to being something not an integer, then the same is still true. That value and that value are the same. So identities can be explored even if they're not trigonometric identities, to understand the idea that for all values of x, the values should be the same. In this case, many students would think that x times x add 1 is equal to x squared add 1 and not x squared add x. And they would find, if they drew a table of values, that in fact that's usually not true. And so they could see that that relationship is not an identity where the previous one was. So you will find Module 5 of the ClassWiz book also contains information on how ClassWiz can be used with various aspects of trigonometry, including the place of identities, as well as detailed explanatory text which can be copied for students as well as teachers. The module includes some exercises to check efficient ClassWiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating.